Hi, my name is Natalie Sebastian, and today I'm going to be talking about Cross Site Request Forgery. First, I'm going to go over what a Cross Site Request Forgery attack is. Next, I'll go over its vulnerabilities. Then, I'll go into depth on how to implement a Cross Site Request Forgery attack on both GET and POST requests. Lastly, I'll explain a couple of different countermeasures that can be implemented to prevent this attack, and I'll specifically demonstrate how implementing secret tokens can prevent this attack. So a cross-site request forgery attack often occurs when a user is connected to a vulnerable web page and the malicious web page at the same time. This allows the malicious site to send an HTTP request back to the vulnerable web page, which is otherwise known as a same-site request. So CSRF attacks often happen because the victim's browser may be tricked by this malicious site that is disguised as the victim. And there are two types of approaches to CSRF attacks: an HTTP GET request and an HTTP POST request. So here's a diagram depicting an example of how a CSRF attack works. So say that the victim's logged into some type of banking website. First, the attacker forges a request for a fund transfer to the website. Then they embed this request into a hyperlink and send it to the visitor, or the victim. The victim then clicks on this link, inadvertently sending the request to the website, where the website validates the request and funds are transferred from the victim to the attacker. The reason so many web pages are vulnerable to this attack is because servers are not able to distinguish the difference between same-site and cross-site requests. A same-site request is when there's a request sent from web page A to web page A's server, whereas a cross-site request is a request going from web page A to web page B's server. So attackers can take advantage of this by forging requests that are exactly the same as a same-site request, even though it's really a cross-site request. And the problem with cross-site requests is that the browser will still attach all of the cookies it normally would in the same-site request. So here's a diagram that's just showing the differences between a same-site and a cross-site request between two different websites. So first I'm going to go over how to perform a CSRF attack on GET requests. So a GET request is used to retrieve remote data, and the fields needed to create a forged HTTP header for a GET request consist of the victim's user ID, otherwise known as the GUID, and the GET request URL. And both of these fields are going to be used to create the image header, which is going to be within the HTML code that's going to be linked to the attacker's website. And below here you can see an example of an IMG header, which I'll be showing you in my implementation demo video. Steps to perform a CSRF attack on a GET request consists of first having the attacker placing an HTML code within the malicious web page. Then, the victim is lured somehow to click on this malicious web page. Once they do so, the attacker's forged GET request is sent to the victim's server. Then, the GET request action is performed without the victim's knowledge. So here's a brief overview of the steps I'm going to be taking in my demo video. First, I'm going to examine a GET request header data. Then, I'm going to inspect the HTML code to find the GUID. Next, I'll write HTML code to embed the forged GET request. Then, I'll trick the victim, who in this case will be Alice, to go to the malicious web page. Then, Alice will click on the web page and I will check her notifications bar and see that the attack was successful and Bobby was added without her knowledge. So now I'm going to demonstrate performing an HTTP forgery attack on a GET request. So in order to do so, I'm going to have Alice add a friend. She's going to add Bobby to her friend list. Before I hit add a friend, I'm going to right click and inspect the page element using the HTTP header live add-on. So I'm going to click on the network tab because this is going to show me all of the HTTP requests sent when I hit add friend. So now I hit add friend, and we can see here that an HTTP GET request was posted. So when I click on this and expand it, we can see that the request URL is a URL used to add a friend. I can also click on the Raw Headers button and see additional information for the HTTP GET request, such as the cookies and other types of data. Now I click on the Inspector tab, and I'm going to scroll down to the section that says Script. I'm going to expand this section so that I can see the GUID of both Alice and Bobby. So here I can see that the GUID for Alice is 42. And right below, the GUID for Bobby can be seen as 43. So Bobby's GUID will be used to implement the attack by putting his GUID into the URL within our HTML code. So now that I have this information, I'm going to open up the terminal and go to the var www CSRF attacker directory. Within this directory, I have a file called index.html, which is embedded within the malicious attacker's webpage, www.csrflabattacker.com. So within this file, I have a header that says this page forges an HTTP GET request. Below that, I have an image header that contains the URL we saw within the GET request. And I have it equaling to 43 because this is Bobby's GUID, and we want to add him to Alice's friends list without her knowledge. The width and the height are set to 1 so that the pop-up will be small so that Alice will not notice that Bobby was maliciously added to her friends list. So now I'm going to go back to Alice's profile. And she received a message from Sammy, one of her friends and Bobby's friends. So Sammy sent her a message saying, "Check out this really cool link." So Alice clicks on the message and then clicks on the link, expecting it to be really awesome. But when she clicks on this link, she's instead redirected to a page that says, "This page forges an HTTP GET request." So now, if I open up a second tab and go back to her profile homepage, we can see if the attack was successful. So as soon as we get here, we can see on the top right there's a message saying you have successfully added Bobby as a friend. And we can also see that Alice is now a friend of Bobby, even though she did not add him as a friend. He was maliciously added due to the forged HTTP GET request. Next, I'm going to explain how you can implement a CSRF attack on post requests. A post request is used to insert or update remote data. The fields needed to create a forged HTTP header for a post request include the victim and the attacker's GUID, the post request URL, the description value, and the access value. All of these fields will be used within a JavaScript function within the malicious HTML code. Now, this code is going to be slightly more complex than the HTML code we saw in the previous GET request. The steps to perform a CSRF attack on post request is very similar to how you would implement one on a GET request. The attacker is going to place the HTML code within the web page. The victim then clicks on this malicious web page, and by doing so, the attacker's forged post request is sent to the victim's server. This post request action is performed without the victim's knowledge. Here is a rough overview of the steps I'm going to take to implement this attack. First, I'm going to examine the post request parameter data. Then, I'm going to examine the post request header data. After that, I'm going to write the HTML code to embed a forged post request in the malicious web page. Then, I'm going to have Sammy trick Alice again to click on the malicious web page, and then Alice will check her profile page and see that the description was added to her profile without her doing so. So in order to implement the forgery on a post request, I'm going to have Alice edit her profile and then hit save so I can first examine the parameters within a post request. So I'm going to inspect the page element again using HTTP header live and go to the network tab. Now once I hit save, an edit profile post request will be generated. So within this post request, similar to the GET request, I can see the request URL, which is the profile edit. I can also examine the raw headers button and see similar information I saw in the GET request. The remaining information we need is in the params tab. Here, we can see the access levels, GUID, and name of Alice. The access levels are all equal to 2, which means that anybody can view those fields. The field that we're worried about is the description field, which is where Bobby wants to add his message, "Bobby is my hero," to Alice's profile without her knowledge. So now that we know what's needed to create our HTML file, I'm going to go back to the same directory I did to perform the GET attack. Within this folder, I have a file named index.html. At the top, I have a header saying this page forges an HTTP post request. Then below, I have a JavaScript function. This function contains various fields. The first field contains the name value setting equal to Alice, which we saw in the post request. Then I'm going to set the description value to say Bobby is my hero, with the access level set to 2 so that everybody can see it. And then lastly, the GUID value is set to 42, which is Alice's GUID. And below here in p.action, we can see the request URL that is going to be used to edit her profile. So now that we have this file created, I'm going to go back to Alice's profile, and she has another message from Sammy. This time, Sammy sent her a message asking her to check out this awesome link. Alice clicks on the link and is quickly redirected to her page where she sees a profile was made and Bobby is my hero was added to her profile without her knowing or doing so. Next, I'm going to go over a few countermeasures that can be implemented to prevent this attack. The main cause of CSRF attacks is due to the server being confused. In order to help the server, there are a few things that can be done, such as implementing a referrer header, same-site cookies, or secret tokens. A referrer header defends against CSRF attacks by determining where the user came from. However, this is not commonly used due to its many disadvantages. Its header is poorly specified, its header leaks URL information to other domains, and majority of antivirus programs remove the referrer header from all HTTP requests to avoid leaking sensitive data. A same-site cookie is a special type of cookie in browsers that provides a special attribute that tells a browser whether or not a cookie should be attached to a cross-site request. There are two types of same-site cookies, lax and strict. The advantages of this countermeasure is that if a victim clicks on a malicious web page, the same-site cookies would not be sent with the HTTP request that the attacker was trying to implement in their malicious site. Here is a simple diagram showing how same-site cookies prevent a CSRF attack. The third countermeasure that I'm going to discuss is secret token. This is another special type of cookie in a browser that provides a special attribute that tells a browser whether or not a cookie should be attached to a cross-site request. There are two ways to implement this. One is to embed a random secret value inside of each web page, and the other is to embed a random secret value inside of a cookie. The advantages of this countermeasure are because the secret value is randomly generated, it is different for every user, therefore making it impossible for an attacker to guess or determine what the secret value is. I'm going to implement the secret token countermeasure. So I'm going to go back to save and edit Alice's profile so that I can show you the two types of tokens that are already set up in the ELG service. So if I go back to the Network tab and hit Save, we can re-examine the post request from earlier. So within this request, under the Parameters tab, the first two tokens here can be seen. However, during the earlier attacks, their function was disabled. So in order to implement this countermeasure and see if it is successful, I need to go and edit the gatekeeper function within this file. So here's the extension to get to the ELG folder, and within this folder I need to make an edit to the following file. So I know that the gatekeeper function is about 61% of the way down, so I'm just going to keep scrolling until I find this function. Almost there. Okay, so here we can see the gatekeeper function. Now this return true statement is what we want to comment out. By doing so, the countermeasure will be enabled, and the CSRF post request should no longer be forged. So I'm going to go back to Alice's profile page and go back to the message that Sammy sent her and click on the link again. Now this time when I click on the link, we're sent to the page that says this page forges an HTTP post request. We're never actually sent back to her profile page, meaning that the script in our HTML file never actually ran. So now when I go back to her profile homepage, we'll see that there's a bunch of these errors because the HTML file wasn't able to properly run the script, and that her profile has no description. Overall, the main cause of CSRF attacks are due to the server's inability to determine the difference between a request from its own web page or a third-party untrusted site. With no countermeasures, this inability can lead to victims being tricked into clicking malicious web pages, where the attackers can then launch forged requests against the victim. Users assume that web pages they are visiting are safe from these attacks. However, some web developers are unaware of the problems CSRF attacks can pose. It is important that users learn how to protect themselves from CSRF attacks, especially as technology continues to advance. Fortunately, preventing these attacks is quite simple, as we just saw, and there are various different mechanisms that can be implemented. Thank you.